Welcome back, students. Today we'll be solving the problem to determine the support reactions for the beams as shown in the figure. Now you can see it is a single overhanging beam, single or just an overhanging beam, because only on one side the beam is being extended. On the other side it is literally supporting on the support. It is A, B, C, D is a beam which is overhanging. At B you find the roller support, and D you find a hinge support. Okay, roller support and a hinge support. So coming to the type of loading, you can see here on AB span there is a triangular load. You can observe this is a triangular load, correct? And between BC span you find one more triangular load, and between C and D it is a trapezoidal load. The shape, it takes up the shape. Okay, convert this AB into AB load into a point load. So I'll refer separately as AB. AB, what is the intensity of the AB? The load AB, the intensity of the load AB, it is 20 kilonewton for a length of 3 meter. 20 kilonewton per meter for a length of 3 meter. Okay. Now convert this 20 kilonewton into, because of triangle, it is half into 3 into 20. So you get it as 30 kilonewton. Where it is acting? From the apex. You should identify the apex. This is the apex. From apex, it is acting 2/3 of the length. So it is 2/3 of 3. So it is acting at a distance of 2 meter. So I'll be representing AB with a point load. Instead of a triangular load, I'll be representing point load. So this is point load, which is 30 kilonewton, and it is 2 meters here and 1 meter here. Similarly, do it for the BC load, which is spanning on BC. You find this is the BC, correct? And what is the intensity? Okay, I'll complete here also so that you get a picture of a triangle load. And what is the intensity? It is again 20. It is again 20 kilonewton per meter and spanning for a length of 3 meters. 3 meters. So convert this half into 3 into 20. You get it as 30. Apex is, this is the apex. And it will be acting as 2/3 of 3. So it is 2 meters. Okay. So where it is acting between B and C, it is converted, the whole thing as a triangle load is converted into a point load. 2 meters, it is 2 meters here and 1 meter is here. So the load value is 30 kilonewton. Okay. And the last one is the other, not last, I mean to say that a trapezoidal load 30 and 10 and 30 for a span of 5 meters. So this is 10 and you find this is 30. This is 30 kilonewton per meter. This is 10 kilonewton per meter. So I can divide it 5 meters. I can divide it into 2 parts. The label of it CD. Points are C and D. So this is C and D. C is here, D is here. So I convert this as a UDL, which is having 10 kilonewton per meter, and plus this is for 5 meters. For a better understanding, I am giving this indication. Again 5 meters, C and D. So you find this triangular, right? This is UDL. So you find 20 kilonewton per meter. So which is acting as a triangular load. So therefore I divided this trapezoidal load into one UDL and one triangle. So now convert this into a point load, C and D. So it is C, it will be acting as 50, 10 into 5, 50 kilonewton. Okay, and this is 5 by 2 and 5 by 2. And this will be plus, convert this, which is half into base into height. So here you find like something like half into 5 into 20. It is 50 again, 50 kilonewton. Here also kilonewton. And the distance of this load will be 2/3. 2/3 of 5. What is 5? The length of the span. So 2/3 of 10 by 3. And this will be remaining 5 by 3. Okay. Fine. So this is 10 by 3 and 5 by 3. So now we can draw, once you do all this, you can represent in the form of a ground load. Sorry, free body diagram. This is how it appears. So at roller support, you find only one reaction. At hinge support, you find two reactions. Upon solving equations of equilibrium, substituting the values, you get RD value, RDY value, or RBY value, which I represent it as VD and VB, right? And this will be, I'll be representing as RD, or the reaction at the resultant at the point D. Okay, with this, I'll end the session, students. Thank you all.